In this set of video notes, we're going to look at 6.4 factoring polynomials, and we're going to look at the factor theorem to determine whether factors are factors of a polynomial given in our problems. So recall that if a number is divided by any of its factors, the remainder is 0. Likewise, if a polynomial is divided by any of its factors, the remainder is 0. The remainder theorem states that if a polynomial is divided by x minus a, the remainder is the value of the function at a. So if x minus a is a factor of p of x, then p of a equals 0. So we can take a look at example A. So if we have a linear binomial, so that means x to the first and there's two terms. If it is a factor of a polynomial, then it should equal 0. So determine whether the given binomial is a factor of the polynomial p of x. So in this case, we know that if it's x plus 1, that x is equal to a negative 1. And if we take p of negative 1 and plug it in to our polynomial, then it should be 0 if it truly is a factor. So in this case, I have negative 1 squared minus 3 times negative 1 plus 1. Negative 1 squared is 1. Negative 1 times negative 3 is a positive 3 plus 1 and equals 5. So in that case, x plus 1 is not a factor. Because if I plug in negative 1, I should get 0, and I did not. So let's try the next one. So in this case, we know x is equal to a negative 2. And if we plug it in, we have p of negative 2 equals 3 times negative 2 to the 4th plus 6 times negative 2 to the 3rd minus 5 times negative 2 minus 10. So negative 2 to the 4th is 16, so 3 times 16 plus negative 2 cubed is negative 8 minus 5 times negative 2 minus 10. So we have 48. 6 times negative 8 is negative 48. Negative 5 times negative 2 is positive 10 minus 10. So 10 and 10 cancel, 48 and 48 cancel, that makes 0. So p of negative 2 equals 0. So yes, it is a factor. For letter C, again, we know that the x is negative 2. So p of negative 2 equals 4 times negative 2 squared minus 2 times negative 2 plus 5. Negative 2 squared is 4. 4 times 4 is 16. Negative 2 times negative 2 is positive 4 plus 5. And 16 plus 4 is 20 plus 5 is 25. So p of negative 2, this is no. And then letter D, if we have 3x minus 6, we want to find out what x is, so we add 6. 3x equals 6 divided by 3. X equals 2. So we want to do p of 2. So that'd be 3 times 2 to the 4th minus 6 times 2 to the 3rd plus 6 times 2 squared plus 3 times 2 minus 30. And we have 2 to the 4th is 3 times 2 to the 4th is 16 minus 6 times 2 cubed, which is 8, plus 6 times 2 squared, which is 4, plus 3 times 2 is 6 minus 30. 3 times 16 is 48. Negative 6 times 8 is negative 48. 6 times 4 is 24, plus 6 minus 30. 48 minus 48 is 0. 24 plus 6 is 30. 30 minus 30 is 0. So in this case, p of 2 equals 0. So yes, 3x minus 6 is a factor. Now we're going to look at factor by groupings. We want to know what polynomials multiplied together make the given polynomial. So we're going to split it up. I'm going to rewrite as x cubed minus x squared plus negative 25x plus 25. Because minus 25 is really plus a negative, so I'm just going to add those two things together. And between x cubed and x squared, I know that there's an x squared in common. And then if I take out x squared from x cubed, I have an x minus x squared from x squared is 1. And then plus, and then between these two, they have a negative 25 in common. So if I divide a negative 25 here, I just get x, and I divide this by negative 25, I get a negative 1. So notice that this is one term, and this is another term, because they're added together. So I can say both of them have x minus 1 in common, so I am going to factor out x minus 1, and then what's left is x squared minus 25. And then I know that this, so we still have x minus 1. I know that x squared minus 25 is really x squared minus 5 squared. So I know that's a difference of squares. So I have x times x and a positive 5 and a negative 5. Whoops. It's really 5. So, factored form, x minus 1 times x plus 5 times x minus 5. That's my answer. And then for b, I can write that as x cubed minus 2x squared plus a negative and 9x plus 18. And then I'm going to look and see what's common between x cubed and 2x squared and x squared. So if I divide out x squared here, I just have an x left. Divide out x squared here, I get negative 2. Plus, and then between negative 9x and 18, I can take out a negative 9. If I take out negative 9 here, I'm left with x. If I divide negative 9 here, I'm left with minus 2. And then I know that x minus 2 and x minus 2 are the same. So x minus 2, because they're two separate terms. And then what's left inside is x squared minus 9. And I know that that's the difference of squares. So I have x plus 3 times x minus 3. And x minus 2 is still there, because this is really x squared minus 3 squared. And then my final answer, x minus 2, x plus 3, x minus 3.